Hello once again and welcome to our latest webinar. Today's topic is Convergence and Evolution in Indoor Wireless. And we're very excited today to have as our guest speaker, Dean Bubley, who's the founder and director of Disruptive Analysis. Dean is a prominent tech industry analyst and consultant specializing in telecoms, mobile, and wireless. He's a very busy guy. He speaks at 30 plus conferences per year. So this is a great opportunity for all of us to listen to him and ask some questions in the end. Also joining Dean is our iBwave product manager, Ziad Akoshidid, who will discuss a bit about iBwave and its solutions. Ziad is currently attending WLPC in Lisbon, and he's joining us from there. So just before we get started, I just want to go over some housekeeping slides. As always, you will receive a video recording of the webinar by email very shortly. And during the webinar, please ask your questions using the GoToWebinar questions box, and we will answer the questions towards the end of the webinar. And now, without further ado, let's get started. Over to you, Dean.
Thank you, Amna. Hi, I'm Dean Bubley. I'm an industry analyst and futurist. I cover a whole variety of areas, but I'm going to focus today on indoor wireless and what that means in the era of 5G and Wi-Fi, whether it's convergence or divergence, we can discuss later on. So a bit of background for people who don't know me. I cover a lot of different areas. You'll see me comment on various aspects of telecommunications and private communications networks. My focus today is on the in-building cellular and Wi-Fi and to some extent IoT connectivity, and I look at the evolution of 5G and policy, spectrum, things like eSIM and network strategies for carriers and others. I also do quite a lot of work looking at the future of voice, video, messaging for personal communications, and that sort of potentially also factors in today's discussion if we think about future use cases of networks indoors. So it may well be AR and VR, for example, with extreme requirements on wireless. And lastly, one of the topics that I've been doing more on recently is what I call telecom futurism. I meet quite a lot of futurists who, I'll be honest with you, don't really understand the internals of the telecoms industry, the regulatory issues, the legacy issues, the technology integration challenges, and so forth. And equally, there's quite a lot of hype often in the telecoms industry about various future trends outside of the normal day-to-day networking. So, you know, the impact of Bitcoin and blockchain, IoT, drones, robots, AI, and so on. So I'll try and blend all of those, and I'll look at some of the intersection points between the different trends I'm seeing in the market and how that factors into in-building wireless, which I think is a massively understated and underestimated part of the equation. I should probably say that today I'm probably going to be posing more questions than I am giving answers, but hopefully it should give people a set of reference points for thinking about sort of future planning and this concept of future proofing. We certainly aren't going to be able to know everything that will happen, but we can certainly test our assumptions against a set of scenarios that might. So in terms of where we are today for in-building systems for wireless, there's a mix. I mean, primarily we have distributed antennas. A number of locations have small cells of varying sorts for particularly 4G, in some cases 3G, 2G coverage, and of course Wi-Fi and implementations there for a variety of uses, whether that's for guests or for employees. And there's additional wireless standards like Tetra for public safety that are also supported. And I say indoors, sometimes we also consider on campus where you have extended connectivity requirements across, it could be a manufacturing facility or an oil refinery or all sorts of other complex physical buildings and locations. And I see three sets of challenges that are going to occur certainly in the medium to long term. And to some extent, these happening already. But I think if you look out sort of 3 to 5 years, there's a lot more happening around IoT and 5G. And then beyond that, there's a whole range of possibilities. I categorize those three challenges, and I'll drill into them in subsequent slides, as technology issues around future radios, application and user issues, and the way in which wireless networks get used and the purposes they're used for. And then stakeholders, who's actually involved in not just deploying indoor systems, but also expecting to access them or influence how they get adopted. And today it's already quite complicated, where you have venue owners, carriers, potentially occupying tenants, and maybe other groups as well, and that's going to proliferate further in future. So diving straight in, probably the key thing to note as we go towards 5G is the use of newer and more frequency bands that will need to be supported by either the antennas or the small cells, or perhaps multi-radio units that combine cellular with Wi-Fi and other technologies. And we've got a lot of changes that are occurring, both in terms of the frequency bands, but also in some of the underlying technologies which are going to be part of 5G and future Wi-Fi, which might also influence indoor wireless design. The most conspicuous for 5G is the expectation of very high bands in the 20 to 80 gigahertz range, potentially. And there's a few like 24, 28, 32, 38 gigahertz, which are being particularly discussed, either for fixed wireless access, last mile drop from a fiber node, but potentially for ultra high bandwidth in short range applications as well. Also worth noting that 60 gigahertz is being used by WiGig, which is a Wi-Fi enhancement, 802.11 AD and AX, if I remember correctly. There's some new mid bands, which these are interesting because they tend to vary depending where you are in the world. But certainly 3.5 gig is being talked about, up to 4.2. Others that are in the 4 and 5 and 6 gigahertz range as well. And there's a mix of technology and licensing regimes that are being considered here. I'll talk about the impact of possible spectrum sharing as well in a minute. It's also worth noting that we're starting to see cellular technologies, like notably LTE, working in bands that are previously used for Wi-Fi, so LTE-U, multi-fire, and LAA, for example. And that complicates matters when it comes down to stakeholders and who's going to be using which bands and has perhaps service requirements. And then lastly, I'll say there's a growing number of lower bands in use, and particularly there's interest in the unlicensed ISM bands for low power wide area technologies like LoRa and Sigfox. On the bar on the right, it's also saying there's going to be some interesting challenges. The assumptions in 5G is that we're going to be using massive MIMO, that's multiple antennas, beamforming, and various other techniques to improve, whether it's coverage or throughput, multi-point, new mechanisms for mobility. There's some sensing technologies required for spectrum sharing models like CBRS. We might find even AI moving down into the radio network and reconfiguring things dynamically. I would say that a potential issue is we don't quite yet know what 5G is, when it's going to appear, and what it's going to look like. And this is a sort of iterative problem. I don't buy this idea that we're going to have these three sets of use cases all at the same time in 2020 as the massive IoT, ultra low latency, enhanced mobile broadband. I think it's going to be much more nuanced, very country specific, and very also business model dependent as well as technology dependent. I think some of the IoT use cases will come later because there's more moving parts and potentially less revenue and profitability. So I think that no one's going to be ripping out their 4G low power IoT networks like NB-IoT 2 years after they're implemented them or upgrading them, and we'll see a slow move to densification and better services. So that's an additional set of complexities which I can maybe cover in the questions if people are interested. Spectrum sharing I've referenced already. This is a really interesting thing because it ends up with whether we have spectrum sharing and infrastructure sharing at the same time, whether we have multi-radio nodes, whether there is requirement in building for a new set of service providers. For people who are unfamiliar, probably the two most important things at the moment are CBRS, which is a US approach to having spectrum sharing in the 3.5 gigahertz band, and multifier, which is the ability for private users to implement LTE networks in unlicensed bands traditionally used for Wi-Fi. There's frankly a whole day's worth of discussion that we can have here, and there's also some interesting issues for regulators and policymakers to consider, particularly if we think about factories of the future or industrial facilities where large organizations will want to run their own networks the way they do with Wi-Fi or their LAN, for future mobile use cases such as robots or drones on site. There may well also be some wide area considerations, but that's out of topic for this report. And the impression I'm getting from the regulatory community, I was at the ITU meeting last week, is that there is a recognition that some form or forms of spectrum sharing will be increasingly important because there are so many people who wish to use radio resources. There are so many incumbent users that are difficult to move, such as government users or satellite. And so we'll need to have mechanisms to work around existing users, to protect the new users, perhaps indoors. And that then brings in a whole set of new, well, whether they're service providers, I'm not sure you call them that, some of the infrastructure owners. Another area which is shifting fast is around edge computing. There's various technology architectures being put forward to have compute resources in the network towards the edge. The idea being for low latency radio is no use if your data center is 2,000 miles away, and it makes much more sense to offload some of the computing workload much closer to the radio and the end devices. I have seen very little discussion how this intersects with in-building. I think there's an assumption by some in the vendor and carrier community that these edge nodes might go into cellular aggregation centers, or there may be multi-access edge compute for fixed as well as mobile. But for some of the more advanced use cases, there may be a need to have compute capability, again, in building. You can imagine if you have lots of wireless connected video cameras, you don't want to be backhauling HD video all the way back to the core of the network if you can process some of it locally and maybe just send the data that's needed. The same thing for IoT use cases. So I think that from a design point of view, at the moment this is an unknown. This, like 5G, is in a state of flux. But I think that venue owners and carriers and neutral host organizations that are looking at in-building solutions at least need to keep an eye on what is happening on the compute space as well as the radio and spectrum side of things, and work out what the optimum way of blending those might be in future. So moving on to the use cases and applications that I see changing indoors. I think it's worth saying that there's going to be a much wider variety of usage types for wireless connectivity overall. We're used today for the main uses of wireless either being smartphones and laptops for people, and then perhaps whether that's on Wi-Fi or cellular. But then there's also some low power requirements, for perhaps short range Bluetooth, low energy for beacons, or public safety radios like Tetra. But the number of user types and categories is massively going to proliferate, and a lot of that is down to IoT, both fixed IoT, things like sensors, but also increasingly we're going to have mobile IoT, drones, robots, self-driving vehicles. and so on. So if you can think forward 5-10 years, we might have a situation where you have a self-driving car in a basement car park. You might have an airport terminal with self-driving luggage carts or security robots. In a hospital, you may well have automated trolleys moving supplies or even patients around the building. And that's going to really quite alter the patterns and profiles of wireless requirements. And you may well find that in some cases, these other devices or moving objects go to parts of the building, say ceiling voids, that humans don't. And that again needs to be considered for future wireless connectivity. This is going to get even further more complicated by the fact that each industry, and possibly even each building, will have its own very specific requirements, partly as a function of the industry they're in, but also the stakeholders who are there. So obviously airports, for example, have a lot of both safety critical aspects, but also lots of tenant organizations, whether those are the airlines, the caterers, the maintenance companies, or even the retailers not inside the terminal, all have their own separate sets of requirements and separate application cases. You'll have some really important issues around safety and regulatory that apply where you have intersections of the network and telecom regulation in some cases with industry-specific regulations in healthcare or manufacturing. And that may have some notable impact on things such as liability insurance if connectivity fails or is not always in the right place at the right time with the right capabilities and qualities. And I think that we're going to end up with a set of niche service providers and integrators and consultants who are helping both the venue owners but also their service provider partners think through some of these issues, whether it's a smart factory in the future or whether it's a hospital with surgical robots and connected devices. And so one of the things I would say is that when thinking about wireless connectivity and indoor requirements in particular, it's almost like sort of war game the future applications. Think through what does it mean to be on a trading floor in an investment bank in the year 2025 or a sports stadium. Are you going to want to have real-time video or even VR replays from 30,000 people across the stadium? Are you going to need to support ultra-low latency trading applications to wireless devices? Are you going to have business building as a service where you have different ownership models of the building where connectivity is part and parcel? What does that mean in terms of having proven capabilities, but also more manageable and more future-proof ones for upgrades as required? In fact, one of the things I've noticed is that connectivity, whether that's wired or wireless, is starting to become so critical as impacting on building valuations. I came across this organization recently, Wired Score, that gives buildings a ranking based on their telecoms infrastructure capability. And added to, as I said, newer models of building ownership and service provision, and also construction materials, which we'd like to change over time with environmental requirements. And we have another set of variables to contend with over the next 10 years or so. Last point is around the service providers who will need access to in-building infrastructure, whether that is Wi-Fi, whether that is cellular, or whether it is something they're deploying themselves. Historically, we can pretty much divide up the service provider universe into some fairly small categories. There's licensed mobile operators who own spectrum and sort of MVNOs, so essentially wholesalers. The fixed and others are less relevant here. In future, we're going to find a whole set of new service provider types. You might find hybrids, so it might be an MVNO that has some shared spectrum or locally licensed spectrum in hotspots or in particular buildings where it's important. You're obviously seeing infrastructure being outsourced by the carriers to separate tower companies. There's a growing proliferation of types of Wi-Fi service provider and Wi-Fi first with cellular backup and so on. And you're going to find additional service providers that may have a stake in building coverage. I mentioned the underground car park before, but you can quite imagine that there's going to be specialized vehicle related mobile operators or wholesale providers or IoT connectivity providers that suddenly find it really important to understand the connectivity dynamics in an underground car park, let's say, and perhaps may even be prepared to contribute to the costs. The same thing is true on the fixed side, and there's going to be a variety of others who are emerging as well. I'm not going to go through all of this, but the one I highlight is around the venue service provider, and there's going to be perhaps a model of neutral host for wireless for venue owners, simply partly as a revenue stream, partly as a way of funding the necessary investment, but also in as a way to provide their visitors or tenants with a set of new service capabilities as well. If you think of this sort of everything as a service mentality, that very much fits with this. So what we get is this huge fragmentation, and my suspicion is that Wi-Fi becomes more important rather than less because of delays potentially with 5G, and also a variety. When I speak to IoT vendors, there is often an assumption that Wi-Fi is still the preeminent approach for sort of mid to high bandwidth use cases, as well as the low power devices. But we're going to see cellular operators, even if the carriers themselves are converging, there are likely to be new, perhaps private operators because of CBRS and multiplier. You're going to find vertical specific organizations that could be dedicated network operators for the public safety sector or the mining or airports or manufacturing. And this is also going to be further complicated by the sophistication of network slicing in the core network, which is designed to encourage a new set of stakeholders on the core of the network, and that will translate almost inevitably to the radio as well. That said, it's worth making sure that people realize the complexity of setting up some of these new ideas, and it's more than just the radio and the spectrum required. If I was going to set up a private or enterprise mobile network operator, I need to think through everything from the numbering and provisioning, the core network, application platforms, roaming interconnect. There's a whole host of regulatory considerations from lawful intercept to, again, to numbering and so on, as well as hoping that there's available supported devices in my chosen frequency bands. So, added to the planning and sort of future-proofing aspects, I think we should probably expect there to be quite a long transition before we get to a world in which there's not just the traditional carriers, traditional venue owners, but this huge proliferation of other wireless operators of one form or another. And I think in the meantime, we're going to have an awful lot of hybrid solutions, converged platforms. Again, as I say, Wi-Fi either used as offload or as a native owned solution for IoT. As I say, I apologize for perhaps raising more questions than providing answers here, but I think it's important to recognize that the sheer number of dynamics and variables at play, and therefore at the very least the requirement for more discipline in thinking through the possibilities. You're not going to be able to cover all the possible outcomes, but by at least giving thought to them up front, a set of reasonable scenarios, you started the future-proofing planning and integration process. Thank you very much.
Thank you, Dean. So a little bit presenting myself. My name is Ziad Akil-Shadid, and I'm a product manager here at iBwave. The subject of convergence in the network and the in-building is something that we are looking at very closely, and it's of immense interest to us. And that being said, I would like to highlight the challenges that we see coming to cope with the capacity throughput demand, in addition to new technologies, as we just heard Dean describe. So looking at the whole ecosystem from a time domain perspective, just it's another twist on looking at the challenges that we're going to face. So we're gonna, some slides. We're gonna go through some slides on concept, high-level stuff, followed by very down to earth with numbers, slides with numbers, looking at some case study, and then finishing up with some cool, colorful slides before wrapping up the webinar. Next slide, please.
Do you want me to build?
Oh, yeah, please. So, although it is clear to most, it is nice to put the ecosystem into perspective. When you're dealing with medium to larger deployments in building, then you have multiple actors and multiple entities, and you have different aspects of the deployment. We're going to come back to that in the case study just to put it more into perspective. You want to building, surveying, designing is something that we all think of, and something that actually takes most of the time. But also there are other things that we need to highlight, and collaboration is a big one. For example, between system integrators and operators, or different departments within operators, and so forth. Maintenance is another thing. What happens when you have deployed the big network and you want to come back and augment it, and so forth. Also, there's a process management aspect to the whole project, the whole deployment, and it's also a time consumer. So we can maybe go to the next one. Next slide, please. So let's look at the case study. It's a case study that has been done a few years ago, but it's still relevant, I believe, for many reasons. So it's a hotel complex in India, fairly large, 437 rooms, thousands of users, with different demands on the network. If we go to the next slide, we can see a little more into detail what kind of profile we have for the users. Next one, please. Yeah, thank you. So in this case, we had thousands of users with different throughput requirements, and also, as we can see, we have a split of technologies. So this is a webinar about converged networks, and this is an example of converged network with LTE and Wi-Fi. And in the upper left, I don't know if you can see, you can look at the profile of the Wi-Fi usage depending on what type of download, upload kind of profile. All of these things are part of our software, and they come into calculation of capacity and so forth. So this is a little bit an overview of this project, and if we go to the next slide. Thank you. Putting again the ecosystem into perspective, that what we saw in the earlier slide, from design, which is actually in the middle of this, but you have also in the beginning a business case, you have some signatures to get, you have some people to please, and once you've done that, you design, you survey, you design, you build, you have to, of course, maintain and make sure everything continues to work, and in the prospect of augmenting your network in the future. So on the bottom of the slide, we have kind of put our different tools that interact at different levels of this ecosystem, and to represent more visually our solution, our enterprise solution, more with respect to what aspect of the project deployment we are at. So we're going a little bit too fast in these things, but the purpose of this is more to talk about the new challenges. So if you have more questions on that, we can cover them later. So if we can go to the next slide. So we have the numbers of the results that came out of the design, and we see it's I mean, with significant deployment with 390 small cells and access points. We also have 59 controllers and switches, some other thousands of other parts and cabling, 17 kilometers of cabling, and we generated 7 reports. You know, it's a complex, this is a fairly complex deployment, you know, floor plan, blueprints, cable routing, aesthetics were involved, of course, ease of use, power, RF design, the whole thing. And although these numbers are from this case study, which we did a couple of years ago, I would like to come back to them a little bit later. But for your information, the system design in this case was completed in a single visit, lasting 3 days using iBwave, where typically a project of this size would require 3 to 4 visits across several days. So the time saving in this case represents 70% of the effort and design cost. Just a side note here. And this is with our previous software. And as we're going to see later, we are continuously addressing the time-consuming elements and trying to minimize the time spent on a project. Next slide, please. So yeah, let's look at some of the new challenges, and things are going to get more interesting. And what we have introduced in release 9 that addresses some of them. We have introduced a feature for smart antenna countering, and we had a lot of feedback from the community about when doing some precise design, placing the APs on the floor plan and clicking the prediction and then waiting for the calculation to end, and then adjusting and repeating the cycle several times over. As you can imagine, that's pretty time consuming. So we devised this this pretty cool feature, very neat feature, and shows real time as it happens the signal strength of the antenna and the signal source on the floor plan, and you can move it, as you can see from the GIF, and we adjust the contour to the condition, the wall, or the attenuation of the propagation criteria of the space. Of course, we support different algorithms, fast ray tracing, free space path loss, etc. And depending on what you choose, you can do your design, and you see the result automatically as you place your AP and you move it around. So that saves an enormous time. You can place your APs on the floor plan and be very confident that you have a very good layout of your APs, and then run your prediction maybe 1 or 2 times, not many times, and then just to validate that everything's okay. And it's enormous time saving. And just a side note on this slide, I mean, we're showing here on the GIF the smart contouring for an AP that has multiple radios. So it's pretty cool. So this feature plays very nice with a multi-radio AP, which is another feature we're going to discuss in the next slide. Next slide, please.
You got it, or is there a build?
Yeah, this is the first time I'm using GIFs with the GoToMeeting, so it might not be nice. Oh well, okay. Well, I can't see it on my end, but I'm assuming you're all seeing. Oh, there it is. So multi-radio APs. A lot of our partners, vendors, you know, coming out with multi-radio APs, from 2 5 gig radios in the single AP up to 16 and more. Actually, our software supports building a very flexible multi-radio AP. And in this case, when we're showing a 4 radio access point being placed, So higher capacity, density, and throughput requirements mean deploying more multiple radio APs in the future. And we want to take the guesswork out of deploying, modeling the multi-radio APs on your floor plan, as some previous users were doing some ad hoc ways to model multi-radio APs. So now something more streamlined for you, looks better, and it looks also very good on the bill of materials because you have very accurate representation of the multi-radio AP. So if we can move to the next slide, please. And as we saw earlier in the on the case study, I mean, you have significant kilometers of cables that you may have to design. And if we are talking about converged networks, Bluetooth, low BLE, or other IoT applications, and maybe we can start getting the picture that the kilometers of cables we saw earlier, it's something that's going to increase, and you want to spend the least time possible routing your cables in your design plan. And this release, we introduced a cable routing feature. It allows you to trace along the floor plan where your cable routes will go. That would accelerate your cable routing. And we have some early feedback from the real world scenarios where we got some very typical cabling projects. We got feedback that we got some 50% time saving. That's 50% time saving over the cable routing process. So that's pretty significant time saving feature, and it's pretty cool actually. The quick mention here is that if you already have a floor layout with cables already with previous softwares of iBwave, there is a kind of a sister or side feature to this one, which is a magnet to an you can magnet click several existing cables, and then you can route them back to the cable route. So it's pretty easy to upgrade from an existing floor plan to this new feature. Next slide, please. So another thing that we usage that we introduced, another time saving. This thing honestly, I mean, people don't see it as a time saver. I see it as a time saver. If you want to model an antenna using an antenna, a directional antenna, and you don't have a 3D antenna pattern, you're using the 2D antenna pattern, and then you're interpolating the 3D contour out of these 2D planes. You're going to get something that's not very accurate, especially around the side lobes and back lobes of the antenna. And you're going to do your design, and you think everything is okay, and then when you turn everything up, you're going to get a lot of disgruntled users, customers, and you go back and then you go and then measure, and then you realize that, oh, there's something here that I didn't see. And part of that, a big part of that using directional antennas is the 2D patterns. When you're interpolating your 3D out of the 2D planes, you're not getting the full picture. And working with our antenna partners, we're vendors and such, we're getting the 3D antenna pattern modeled in our system, and we're using those to do our predictions and calculations. Of course, that will save you time later. So it's not, it's not a direct time saver, but it will save you time later to go back and then figure out what's happening. So to me, that's that's something that's a big also time saver, especially when you're using multi-radio APs with directional Y-gig. Probably it's going to come directional antennas. Stadiums and such use directional antennas, so it's a pretty cool feature too. The next slide. And this brings us to our Unity, our cloud tool, for to do the rest of the stuff that is involved in the design and commissioning and management, which you need to collaborate. You need to have a single point for fairly medium-sized to big projects. You need to generate reports on different projects at the same time. You need to set up a project plan. All of that, you know, it's a kind of a project management tool, and also a tracking tool of your projects, of your sites. So this is cloud-based collaboration tool. We have APIs also for importing, exporting, interfacing with element management systems and such. So this kind of a thing that this is part of the solution that we like a lot. We're investing in it also, and we think that it's gonna be something very important, more important in the future. Also, once we integrate all the complexities coming that we see coming actually in the future. Next slide, please. So yeah, just to wrap things up, over time. So the whole, you know, you have end users, enterprise owners, service providers, and on all the players in the field, and all of these guys are going to experience more pain with the converged networks, more deployments, higher density. So it's a compounded effect of higher deployments and bigger capacity. It all means that errors will cost you more in time and money if you don't immediately address them. Then it's gonna be more costly to address them down the line. So some of the ways to avoid these kind of costly errors is doing it right the first time, as we saw. Taking the guesswork out of what transpired in the network since the last time you looked at it. Coming back, if you want to do some maintenance and stuff, you want to know exactly in what state the network is. If things changed since last time, you want to have access to that. If some other team did some maintenance and then your team came and then you want to do other maintenance, you want to make sure everything is where you left it. So by knowing where everything is and in what state it is in. And if we go to the next slide, on the subject of knowing where your stuff is from a very smart person, do you know where your towel is? So that's kind of the message here, the underlying message to this presentation. And with this, thank you for attending today's webinar.
Okay, thank you, Ziad and Dean. And now we can go to some of the many questions that people submitted while registering and also right now during the webinar. So the first question is for you, Dean. Can you touch on the most promising IoT use cases for indoor?
Right, okay. Well, this is very, very industry specific. And I think it also depends a little bit on your definition of IoT, whether you're talking about consumer or whether you're talking about industrial or enterprise. I think some of the things that I've seen recently that I've been impressed with were asset tracking is becoming important, whether it's in hospitals or whether that's in factories where expensive items, it could be trolleys or pieces of equipment or tools, are being tagged with wireless devices, which may be cellular connected, they may be Wi-Fi, or they may be something else. So I think that's really important because a lot of businesses don't understand where their assets are. I think other things, there's a huge variety of sensor types that are going into everything from, I don't know, accelerometers for elevator doors through to heating and ventilation and air conditioning systems, obviously security cameras. And I think on the more sort of consumer and sort of multimedia side, I had an interesting demo last week. This is still very early days. But I had a real-time streamed video from a 360-degree camera to an AR headset, which I think was using a prototype 5G network on a South Korean telco's booth at the ITU event. Now that's clearly some way off of mainstream, but I think a lot of the stuff we're seeing around automation, whether that's sort of robotics in factories, is going to will have to become more wireless, because whilst at the moment most robots are fixed in place and tethered, and obviously you can use a fiber, increasingly you're going to have things like trolleys or semi-autonomous vehicles around large sites and buildings. And I've seen some things like room service robots for hotels, quite fun recently. So I think there's no sort of one category. One of the problems with IoT is that there's hundreds, if not thousands, of separate segments, often which have their own software platform, whether they're coming from a telecom company as a service provider, or more likely for an IT or industrial provider. I think that often there's going to be stakeholders who don't really understand wireless propagation, who just expect connectivity to be there when it's needed. And certainly where you have business or safety critical devices, that's going to be a huge concern in the future.
Thank you. So let's go to the next question. How does it apply to industrial IoT, where you need to provide connectivity in large manufacturing factories? What options should one consider for connectivity? And are there any suggested rules for technology selection?
Right. Now that's a really interesting topic. So it depends how large a facility we're talking about. Whether if we're talking about like an airport or a chemical plant, that could be kilometers wide. If it's a manufacturing factory, it's perhaps hundreds of meters. So it depends partly on the scale you're talking about. Clearly on an airport wide or a port, it's not going to be practical to put Wi-Fi absolutely everywhere across a multiple square mile radius, where you've got perhaps large metal objects like cranes or silos or something like that. I think we are going to see need for wide area connectivity. Now then it comes a little bit down to whether broadband or narrowband is more important. So some of the things like sensors reporting on a water tank level once an hour, narrowband is fine. But as soon as you bring in video, where you have requirement for real-time access to cloud IT resources, then we're going to need something that is of sort of probably 4G or in future 5G potentially capability. Then the question comes down to whether or not that network is owned and operated by a traditional carrier, or whether there are opportunities for private cellular networks, either in their own spectrum which is subleased from one of the local carriers. So you get that sometimes in the mining industry, in remote areas where a deal is done with a local carrier who probably doesn't want to put their own cellular infrastructure there, but will work with a local company to run a network, or whether it's the use case is acceptable to use unlicensed bands. And I think that's where things like multiplier and CBRS are going to be important. But there it gets more complicated, because the regulatory regimes are still very early stages around shared spectrum for cellular-oriented bands. I know the UK is looking at some, Australia is, France has a certain amount. I'm speaking at an event in the Netherlands next week, but it's very patchy. And the US obviously is working through the precise rules of CBRS. The FCC is supposed to come out with a notice of proposed rulemaking, I think on October 24th, and that's going to, we're still uncertain about the size of area that will be covered by the priority access licenses for that. So I think that over the next few years, we're going to start to see the enterprise cellular market crystallize. At the moment, there are one-off implementations for smart cities, for public safety, for ports and airports. Certainly some of the big vendors are supporting those. But we don't have a consistent regulatory picture across the globe at the moment. So I think that we're going to have a bit of a wait and see. Now, that's perhaps less of an issue if you're a company like a big oil company that can hire its own radio experts. But I think we're also going to see a proliferation of specialist local consultants and integrators who help to sort of look at the use cases and applications today and tomorrow, the spectrum that's available, and the requirements that would put on, whether that's Wi-Fi, it could be one of the low-power wireless technologies like a LoRa or Sigfox, or it could be private cellular, which is getting, I'd say, in the last 12 months, is gaining a lot of traction and certainly awareness.
Thank you. So there's a question that came in. Can an internal IT department be a service provider to expand their Wi-Fi network using unlicensed LTE network?
Potentially is the answer. I've been speaking to a number of organisations that want to become a neutral host for LTE. But at the moment, we're probably a little way away from all of the moving parts being present. If you think about the interactions you would need to have with the external carriers, you would need to negotiate some sort of connection or roaming deal. There's going to be a whole set of questions about how to manage the billing side of it, the network operations monitoring side of it. It wouldn't surprise me if we see various specialists acting as intermediaries in that case, because I don't think that a typical, even large enterprise IT department is really set up to be a cellular wholesaler today. I think it's quite exciting, but I think it's going to be a journey, and we're probably going to have various interim steps over the next few years.
Thanks, Dean. So there is a question about iBwave. Can I use iBwave for site database and approvals of site proposal? In the bracket, there is a review of drawings and solutions.
Yes. So iBwave has extensive reports, including floor plans and annotations, and definitely it can be used for approvals. Yes.
Awesome. So let's go to the next question. With the major carriers moving away from traditional BTS, how do they play into the future of DAS, or will the enterprise market need to fund the majority of the DAS?
I've got some thoughts on this, Ziad, you may as well. I think it's going to be very dependent on industry and location and buying power of the enterprise. I think you will see some organizations in some countries where the carriers actually want to become deeply involved in a particular industry. So you might be at the port industry or the mining industry or a smart factory. I know a number of carriers are looking at becoming smart factory enabling providers, not just for the connectivity, but even down to sort of monitoring the overall assets and infrastructure in the building. And I think in those cases, you'll probably find that the carriers will decide that it's worth putting a network in order to help them sell their IoT solution. I think in other cases, yes, it will probably be pushed back towards the venue owner or maybe building developer, and certainly as margins shrink, perhaps in the cellular industry, and that's obviously contingent upon things like consolidation as well. You may well find a less willingness by the operators to fund in building coverage. I think where it gets tricky is with 5G. At the moment, there's this sort of still assumption that there's this magical thing that's about to come down the line in a couple of years' time. I think we're going to start hitting the reality barriers when people realize that even if 5G is being deployed outside of the macro network, it won't be working as well indoors. And then it will come down to the terms of licenses for spectrum for a given country and any pressure that's placed on by not just the telecom ministry, but the business ministers in any one country who are hoping that we're going to have this wonderful world of enhanced productivity in future. So I think there's I think there's going to be a lot of debate, a lot of discussion. I suspect that the overall funding picture is going to shift away from carriers to other types of service providers or venue owners. But I equally, I think that that's not going to be happening incredibly quickly. I don't think many enterprises have adequately got the awareness or the budgets for this yet.
Thanks, Dean. So let's go to other questions. The evolution of converged Wi-Fi, LTE, 5G DAS for large venues, big events, and also schools. Where are we now, and where will be in 10, 20 years from now? Interesting.
Zia, do you want to take the first part of that, and I'll
Yeah. Well, the conversions, we are seeing some conversions, of course, and I think that it's going to continue becoming more and more the case. I mean, the whole kind of puzzle of providing lower latency for certain applications and highest throughput and higher capacity. It's still something that we don't have really a clear view how we're gonna address it, and as long as we don't have a clear view or clear solution, we're gonna continue to see, I believe, like more converged networks, and in the short term, like up to 5 years. I don't know about the 20 years. I don't know if Dean, you have a crystal ball.
Yeah, I mean, I suspect we're going to see a combination of convergence and divergence here. I think that some service providers are very bought into everything from LTE, LTE-U to Wi-Fi, and they're looking at deploying sort of combined infrastructure, particularly maybe for public spaces, shopping malls, or they might do a deal with a sports stadium. I think conversely, locations which are more employee-centric rather than visitor-centric will probably want to keep their own Wi-Fi for the conceivable future, as well as having multiple external service providers for their cellular. I think on a 10-year view, you start to get into the realm of software-defined radio being able to do some quite cool things, and on 20 years, well, frankly, we may well be talking about sort of quantum networks and something else. But I suspect that we'll end up with lots of hybrids, and certainly some parts of this, things only move quite slowly. I think that it's probably wrong to assume that everything is going to be done by carriers. It's equally wrong to assume that everything is going to be owned by enterprises. And I think that the new class of organizations running their own networks, the embedding of connectivity into other devices and products is likely to sort of lead to probably more heterogeneity, even if some of those are converged examples.
Thank you, guys. So let's just do one last question before we wrap it up. So the question is, what is your opinion of Wi-Fi solutions, voice over Wi-Fi as a substitute for traditional DAS?
Well, a voice over Wi-Fi is something. It's pretty easy to conceptualize and use. But we know the problems that we have with that, the quality of experience, and these are all things that will remain for the time being until they're addressed on the Wi-Fi side. So I don't know, Dean, if you want to add something to that.
Well, I think it's very carrier dependent. I mean, not every carrier has launched voice over Wi-Fi, not every handset supports it, or not every handset plus combination of OS update and firmware and everything else. I think that's one issue. I think another thing is that the voice over Wi-Fi is great for the consumer market. I think that sometimes on the enterprise, it gets a lot more complicated because the Wi-Fi structure is intimately tied up with the security and firewall systems, and may well not have the ability to support as frictionless a connection.
Thank you. I think someone needs to talk to one of you pretty quick.
Yeah, no, it was the phone in my hotel room, but it's I think it's whoever it was has stopped.
Okay, well, we're almost out of time, so I'm going to wrap this up just by reminding everyone that we will share a recording with you guys shortly. If you have any more questions, feel free to reach out to us, and you can check out iBwave solutions at our website, iBwave.com. And thank you, Dean, for a great webinar, and Ziad as well for the webinar. And thank you, everyone, for joining us and staying with us and asking so many questions. Now I'm going to finish the webinar. Thank you, and have a great day, everyone.
Thank you.